All right, guys. So let me share my screen. Then we're gonna start. Give me just few more seconds. Okay. So let me. You guys are able to see my screen, everyone?
Yes, sir.
Okay. Good. So we discussed about the LSA area type, everything. So we left with two topics. That is a major. That is a summarizations, and one is that is a virtual link. So we'll discuss about that step by step. What is a summarization in OSPF and what is a virtual link? So we'll discuss with the virtual link first. I'll explain what is a virtual link. So let me start the routers. So I'll go here and I'll start the routers. I'll go here. R2 also I'll start. I'll go and start the R3. R4. 5. R6. Let me make as a host name. This router host name is R8. I'll make as a host name at R8. I'll do configuration for R7 as well. So let me R7 host name is going to be R7. I have the R16 as well. Why I put 7 and 16 here? Okay, let it be. I'll put this R10, sorry, not 16. I'm sorry. Okay, so what I'll do that I will enable the OSPF in this link. Then we'll see how the virtual link concept is going to come in a picture in concept. So this area, basically area 22, is nowhere connected with the backbone area. So as I mentioned that every area who want to communicate with the your OSPF network, they must attach directly or indirectly with the area back means area 0. That is a backbone area. If they are not going to be connected with area 0, they are not going to exchange the route. And I can just show you right away. So let's suppose I'm going the R5 and I configure this interface. So if I go in the R5, you can see there is no IP assignment on the interface. That is my gig 0 by 3. So I will go here and assign the IP address config t, and simply I'll go here interface gig 0 by 3 IP address. I will use that 58.0.0.5 255 255 255.0. No shit. This is the one thing I'll configure here, and then I'll go in the R8. I'll configure the 0 by 3 as well. So let me go here and do show IP interface brief. Interface is going to be gig 0 by 3 IP address 58.0.0.8 no chat. Okay, do ping. I will try to ping. Let me try to ping. Dot 5 should be reachable. Yeah, it's visible. Now I'll go and assign the IP address for the interfaces. So I will have the all connectivity. So in this network, we are going to assign the 192.168 and 10.1 here. And now 10.8, I'll go into assign on this interface. In this interface, I'll assign this 10.7 and here 10.10. So they are the /24 network. For 192.168 10.0/24. So I will go here in the interface and do show IP interface brief. And interface, I will go on my gig 0 by 1. IP address is going to be 192.168.10.8. 255, 255, 255.0. No shut. Do right. And I will not assign any configuration on the switch. The all port are going to stay in the VLAN one. So they are going to be stay in the same broadcast domain. So I'm just going to change the host name of this switch as a like what is the switch name? Just switch. Okay, no other configuration I'm doing on this particular switch. Now I'll go in the R7. I'll configure the IP on the gig 0 by 0. So let me configure interface gig 0 by 0 IP address 192.168 10.7 255 255 255.0. No shut. Do right. Now I'll go in the R10 router and the interface Ethernet I will use 0. So Ethernet 0 by 0 IP address 192.168 10.100 255 255 255.0. No shit. Do right. So let me just quickly verify if these three broadcast domain address are reachable or not each other. So I can just simply ping from here. I will try to ping 192.168 10.8 should be reachable. Yeah, it's reachable. 7 should be also reachable. So we have the reachability between these three segments as well. And also we have the reachability. So what I can do that I will enable the OSPF between this network. So, and also from this network. So let me go in R7. I'm already R1. So I'll go here and just, also I'll create one of the loopbacks, guys. Okay, leave it. No loopback needed. Leave it for time being. So router OSPF 22. Network, I'll give 192.168.10.0, 0.0.0, 255, area 22. That's it. Right. Let me, no terminal. What was the command? No line console. It's not showing. I want to off the terminal monitor. Okay, I'll see that. So it's showing the duplex
I
error.
think it's no term on.
That's not supporting the command. No term.
No term monitor.
Yeah, that's
No
fine.
term. Yeah.
It's not supporting. Let me check in this router. Might
Okay.
be. What was the command? Anyone able to recall? I just give me 1 second. How to stop log. So Cisco. There was a command, right? No logging console. Sorry, I'm doing wrong thing. So The command is no logging console. Okay, sorry, guys. This is the command. Okay, so this log I am getting now, I just want to stop this log. That's it. So this command is no logging console. This is speed duplex mismatch error. So that's fine. If you run this command, this will not appear in front of my screen. It will show in the log, but not in my screen. Okay, this is done. Now I'll go here, configuration, router OSPF 10. I will use the same process ID and network. I'm going to use 192.168.10.0. Okay, so you can see we have the OSPF neighborship between these two routers. This one and this one have the OSPF neighborship. Now I'll go in the R8 as well. Router OSPF 10 network. This is the one network. Another network I'll configure 58. So 58.0.0.0.0. area 24. So you can see we have the okay, that's fine. We let me create one of the loopback here. 8.8.8. I'll just create the loopback as well. So 22. Interface loopback 8 IP address 8.8.8. Just for the testing point of view. Okay, right. So eventually you guys will see this is my OSPF neighbor. You can see I have a two OSPF neighbor. One is 7, one is with router 10. Okay, why it's showing the 100 IP address? I given the 100. My bad. Sorry. It should be 10, not 100. IP address should be 10, 55, 55, 55.0. Okay, my bad. So you are going to, okay, show IP OSPF neighbor. Yeah, we have a, okay, it will clear the process, clear IP OSPF process. Yes, it's done. Now I'll just go clear IP OSPF process. Yes, and check show IP OSPF neighbor. Still taking as 100. Okay, it will clear the cache after some time. Neighbor ID showing 100. Still, I don't have this IP configured anywhere, but probably after restart it is going to be clear the neighbor. So we have the neighborship. Now I have to configure this router 5. On the 5, I need to build the neighborship with the my new area 22. So R8 still not have the neighborship with the my VIOS 5. You can see only we have the OSPF neighborship for the area 11. So I need to put this leg, this particular link in the area 22. So they have the also OSPF neighborship. Right now you can see only this router have neighborship with this R7 and R10. So I'll need to go here. I can just use the router OSPF 10, right? And I'll just configure the network that is going to my this network. So, oh, we not assign the IP address is still here. Okay, we assign that. Okay, I need to we assign this IP address, and I'll just give that. And let me re-verify.
Area 22, sir.
Yes, sorry, yes, area 22. I was just checking this one. Section OSPF. Thanks, Amrita. So I make this typo. Should be area 22, not area 0. So let me, yeah, we have the section OSPF. Now you can see that we have the OSPF. And now if we check the show IP route, okay, you'll see that you are getting the 8 subnet route here. See guys, we have the very good routing table now. It looks like very production network. You can see this is the 8 subnet is coming also. And if you check for the 192 subnet also, it is also must be in the OSPF table. You go and find this. Where is the 192.168? Let me check it. 192.168.10. So this route is coming as a directly connected. Why it's directly connected? Oh, why it's directly connected? Because we have this loopback created here. You can see. So if this loopback created, this probably we are not going to get this subnet. So what I can do that, let me shut this loopback. First loopback, I'm going to shut that. Loopback 10. Interface loopback 10. I will shut for time being. Later I'll again make it no shut. I'll let me make it shut down permanently for this one loopback. Now it's done. Now if you check it again, show IP route, include 192.168/10. You see you start getting the route from the OSPF. Why it is not installing the route in the OSPF? Because we have the connected route, and connected route, what is the AD value? 0. So this is the region. This is not going to be advertised. So now we start getting this subnet as well in OSPF domain. So we have the 8.8 also from the OSPF. And also we have the 192. But does this going to be advertised in this R1 or R4? The answer is no. Because we are having the OSPF neighborship, but this route will never going to come here. You can see you never going to find 8 subnet or 192 subnet. Even in this R4, you are not going to find. So how we can solve this problem? Show IP route. Anyone know how to solve the problem?
VRRP, sorry, VRP,
What is VRP?
virtual router something.
Virtual link.
That is
Virtual
the
link, yes.
that. So in OSPF, we have the concept that is a virtual link. So virtual link, you can just Google it in OSPF. So virtual link is just one of the method where we can, connect, means how we have to make that. Means this router, let me draw that. This router, which are connecting to the different area. This is the area 22. So it will never going to send the route to the your any other area unless and until this router have somehow connectivity with the area 0. So we have to extend the area 0 from here via the virtual link to this router. So we have to create one of the virtual link. This virtual link is going to extend your backbone area till this router, and then we can exchange the route from here to here without any issue. So virtual router is a feature, or a virtual link is a feature in the OSPF, which is going to help you to build a logical tunnel to connect of your non-backbone area directly with the OSPF backbone area. That's a simple concept. Means this is my non-backbone area, but I want to extend this backbone area. I can use a virtual link. So my OSPF database is going to be exchanged. OSPF strictly dictate that non-backbone area must physically connect to the backbone area 0. But this is how OSPF work. If area separate from the area 0, the routing update cannot reverse network properly. Means it is never going to happen. You can see the right way. If I have this kind of the requirement, my network is not going to be exchanged to this particular uh, area 0 or area 11. Even this ABR is connected to area 11. It's not getting that. Only we are going to get this in R6. So we have to disconnect area 0 if any case failure is going to happen or any isolated new area. So we have to use the virtual link. Virtual link is basically going to solve this problem. So I need to configure this virtual link. How it is going to be configured? Let me tell you step by step. So virtual link is going to be configured between my R4 and the R5. Okay, this is where the virtual link is going to be created. So based on this virtual link, we have to make sure the configuration is going to be identified. And after identify the configuration, we have to just do the configuration step by step. So what configuration need to be identified? Means what is my neighbor, right? And to which I need to build my virtual link. So I already configured, I believe, loopback address here. Yeah. And let me see, we configure the router ID or not. So I'm just configuring the router ID. It's not mandatory, but I'm just configuring the router ID. Just in case you want to go and create the virtual link, only requirement is the network you want to get the virtual link, they are should be reachable. So I can go here and try to ping 5.5.5. That is reachable, which is there. And if I go here in the 5 router, show IP interface brief, and try to ping that 4.4. It is also reachable. So we have the reachability between these two routers. I can make them explicitly router ID. So if I go here and I'm going in the router OSP, it's not mandatory command, but I'm just showing you the best practice. Router ID, I'll just make as a 5.5.5. And I will just clear IP OSPF process to reflect the IP address. So you can see reload or use the clear IP OSPF process command to take this effect. By default, it's not going to be happen. So I will just use this. Okay, I'll go here also. I'll just go in the configuration. Sorry. Wait few seconds. I put the wrong. One more minute. So let me go here and okay, router OSPF 10 router ID. So in case you want to assign the router ID, how you can assign the IP address, this is what I'm just telling that. So clear IP OSPF process. Okay, so let me check show IP OSPF neighbor, show IP OSPF neighbor. We should have the all OSPF neighbors up and working. So you can see we have 3 OSPF neighbor, 2 this one and 1 this one. So all good now. Now we'll create the virtual link. How we can create the virtual link? To create the virtual link, simply we have to go in my area 11 configuration because we need to extend the configuration from the area 11. So I will go here, config T, and I will let me just show you the configuration. Do run section OSPF, and I will go here router OSPF 10, and then I will type area 11, right? Virtual link, and I will just use the virtual link with the loopback address. I can just use the loopback address. Better you have to use the loopback address. Else, if you are going to put the this IP address, it will not form the virtual link because this is a different area. So the link either you can use this physical link, which is part of the area, or you can just put the your loopback interface, which is the part of the area 11. So let me show you. If you see here, Solon section OSPF. So always recommended when you build the virtual link, try to use the loopback address or the address which are part of the area 11. So I'm just going to use the loopback address and this is going to be 5.5.5.5. That's it. This is the one-side configuration. Now I'll go in the R5. R5 configuration, I'll go that. And after that, I will again have to give the router OSPF 10 and area 11, right? And then I'll give the virtual link that is going to be 4.4.4.4. Why 4.4.4? Because you can see this is also part of area 11. So we are getting the virtual link between these two these two IP address. So I'll click
So,
OK.
sir, this is the loopback.
Yeah, loopback address, right? Loopback address. Now wait for a while. You can see we have the new virtual link. You can see this new adjacency. You can see this is the VL0. By default, we have the VL0 because we have just one virtual link. So they form the adjacency with the VL0. If you have the multiple, then it is going to VL1, 2, 3. So now if you check it here, if earlier we have only three neighborship, but now you can check show IP route, sorry, show IP OSPF neighbor, you're going to find that four virtual link. You see, and this virtual link, we don't have the DRBDR elections. That also very important, guys. Whenever we're going to get a virtual link, they will not use a DRBDR election process. Clear? So it's a pure point-to-point link and point-to-point network. So no DRBDR. And here also you can check it. Show IP OSPF neighbor. You have the virtual link. Now, once you make these things and you just go and check the routing table of the R4 now. Okay. Show IP route. You see, you start getting a route. See 8.8. And what is this route? That is a inter area route. And also you start getting a route one. Earlier it was not coming. But the moment I make the virtual link, this route is start coming to here. And if I go here R1 as well, show IP route, right? You'll see that you start getting the 8 subnet. Earlier it was not there. 192 subnet also start coming. And now if you go on the R7, earlier the route was not coming for the 1, 4, but it should start coming. Let me show you that as well. So show IP route and see you have the all route start coming. So if you just ping from here 1.1.1, right, you can able to reach. You can ping from here 1.1.1, it's reachable. You can ping from here 1.1.1 with source 8.8.8. It's reachable. So we have the all reachability, means end-to-end reachability to make this happen. Is it
So
clear?
you're saying that, yes, sir, you're saying router 4 and router 5 became neighbor now.
It was also earlier neighbor, but that
Okay.
was via the physical link. Now we make them neighbor via the virtual link. And that
Okay.
virtual link basically indirectly connecting to your this backbone area to this particular router.
Yes. Okay. Got
Okay,
it.
that's why you start getting this particular route.
Yes. Thank you.
All right, so I believe we are good with the virtual link, everyone. Okay, so the next topic in OSPF, we have the OSPF summarization. So let me stop this recording. Okay, so now we have to understand the OSPF summarizations. So what is summarization? Anyone know what is summarization and why you need a summarization? Anyone have any idea? Maybe you guys learn about this. We discuss in the IGRP as well. So you can use those
Yeah.
concepts.
Uh, to
Yes, to
summarize
reduce
the
the number of
multiple
routes.
band era. Yes.
Okay. So basically in network, yes, Akhil, you want to say something?
Yeah, to reduce the number of routes in the routing table.
Yes, yes. That is the main goal. Means we don't want to put a lot of routes in the routing table. So if you want to just minimize the prefix length, means the prefix number, then we have to use the summarization. So my router will not have to process a lot of prefix and all. They will just only process the few prefixes. Let's suppose in this case right now, if you see in this case, if I go in the my R1 point of view, we are getting a lot of route for 192. No, we are not getting a lot of route from 192. Still, we not advertise, so we are not getting. So let me advertise the route. So if I go in the R5, you can see we have the lot of loopbacks here. Okay. 10 is shut down, so we are not going to use the 10. I'll use the 11, 12, 13, 14, 15. 10 I use for the different network. So let me remove this 10 from here. No interface. I will not use this 10. 10 we are using the for different LAN. And I'll create one with more loopback. Interface loopback 16. IP address 55.55.0. Okay. So you can see here. So now we have these 5 addresses 11, 12, 13, 14, 15, 16. Sorry, 6. So these are my addresses. If I go and advertise this address in the OSPF, so how I can do that? Let me do that. So simply either I can do in 2 methods. I can use the command interface range. Okay. I'll use the range from the loopback 11 to 16. This is the range. And I can configure IP OSPF 10 area 11, right? This is simple command. So that means these all are going to advertise in the OSPF. So you can see the moment I have done, if you go in the R1, probably you're going to find a lot of prefix from the 192 subnet. See, you start getting a lot of prefixes here, 192 subnet, and these all are coming as your specific prefix. But let's suppose these are only 5, 6 prefixes, but you have the 1,000 prefixes, 100 prefixes. So router have to process a lot of, means every router which is receiving this prefix, means every router, this is also going to receive this prefix. So they have to process this all prefixes. Means this also getting a lot of prefixes from 192. R4 also going to get that. So how to minimize this prefix? So to minimize this prefix, we have two kind of summarization. One is summarization is going to happen from the your ABR based summarizations, and one is going to be known as the ASBR based summarizations. So this is the one prefix I'm getting from the my internal OSPF domain. Now let's suppose I have the ESGRP domain, which also going to inject the prefix in OSPF. So how these are going to be summarized? So let me do that also. So if I go in the R6, you are going to find a prefix, a lot of prefix here, show IP interface brief. See, there's a 172 prefix also here. So how I can, let me first advertise, then we'll see that. So these prefix are coming from the external external domain. So OSPF have summarization, that is the ABR summarization, right? Summarization, and another is known as the ASBR summarizations. Okay, so we have a two kind of the scenario in the OSPF. That's very important, guys. So let me just advertise this one. Configuration T. I will go in the router EIGRP 100, and then after what I can do that I will use the network command. I can advertise this all network 5, 11, I'll use 12, I'll use 13, I'll use 14, I'll use 15. Done. Okay, now you'll see here. You also start getting the route, show IP route. See, all OSPF EIGRP route is start getting via D. And already we have the redistribution and all. So if I go and check here as well, 172, we start getting this as external route. So I want to minimize this 192, and also I want to minimize as a 172 subnets, both. So let's focus on the first, where I can do summarization for this one. So whenever I do the summarization, always your internal route summarization means OSPF ABR based summarization, we have to do that. Means any internal route we are getting. So this summarization is going to happen on the ABR router. Whenever this router is going to be sent to other domain, they will do the summarization and the ABR. So I'll go in the R4, and R4 is basically acting as ABR, and I'm doing for the 192 route summarizations. So I will use the router OSPF 10, and after that I will use the area 1 range. This is the command you have to use that. And I want to summarize 192.168 0.0 and 255/16. I want to send that 0.0. That's it. Done. The moment I have done this command and you check that show IP route, you are injecting one of the /16 route here, and that is pointing to a null 0. You can see by default it's creating, and this O, right? You guys able to read this O, right? Not D. Because my side something is wrong. Okay, let me do in this way. Oh, sorry. Give me 1 second, guys. What happened to my... Where is terminal? Give me 1 second, guys. I don't know where terminal might go. Let me find a terminal. Give me 1 second. Where is my terminal? Hmm. Okay, I get back. Sorry, guys. So you can see like it's the OSPF route. Sorry, it's the OSPF route. This has been created, right? And this is null 0. So you can see by default, it's null 0 route has been created under the OSPF. The moment I use the summarizations, that same time they have the OSPF route created in the null 0. So basically that means this router is doing the summarizations. And why it's created null 0 route? Because this is going to advertise this route to the your other areas. And if I go for the my this router, show IP route, and check that, you are going to get summary route somewhere /16. You can see this you are getting a summary route. So you will start getting a summary route on your router. So you can just
So sir, this area 11 range, this is the command to summarize.
yes. So let me just 192.168.0.0. You start getting the summary route. See. So the command is basically this one. We did in this particular router. This command. Let me show you one more time. Show in section OSPF. This is going to be your command. Right? Now, let me explore a few more things. If I go in the router OSPF 10, right, I'm using this command. Right, you can see we have the advertised range also. Do not advertise this range. If you use that, it will not advertise. Advertise this range, it will advertise this range. By default, it is going to use. And if you want to put any cost and all, you can just put the cost and all. I don't want to put any cost, but yeah, this is the things we can do that. By default, it is going to do type. So then after you have the this kind of the prefix, and you can see the summarization is happening on this particular router. You can see. So if you want to summarize, you can do it this way. So this is an internal network summarizations. Now, if you want to summarize the route which is coming from the 172, that is coming from the your external domain. So where I can do the summarizations. So for any external domain summarizations, means which is coming from the your eIGRP, that is not that is need to do on the your basically ASBR based summarization, not the ABR based summarization. It's the ASBR based summarizations. So we have to do the summarizations from the ASBR, right? So how we can do that summarization in the ASBR? So you just have to go in your R5 router, and from there we have to do summarizations. Like If I want to do summarization, so you not have to do in the ABR based summarization. ABR is just for the internal. ASBR is going to use for the your external. So I can use this. Let me go here in the R5, and R5 is going to be there. And you can see there is a show run section OSPF command. And I'll go here and use a router OSPF 10, right? And here I can use that summary address. So this is the ASBR summary command. Means earlier we used a different command. See here the command was this to summarization. Now we are using the summary address because we are doing the ASBR based summarization, and this I can use it. So 16.0.0 I can use the again. So both have the different command and different set of the configuration. ASBR is required this summary address command. ABR is going to require the area range command. Now, if you check on this particular prefix on the R4, show IP route, include 172.16. See, you start getting route as a this summary route. 16. The moment I have done, you will start getting this /16 route. So that is how you can do the summarization for the your any kind of the OSPF. And you can see this is the it's again external route getting from the your external domain. Again, if you go for the your R1, you only getting the your summary route for this as well. Clear? So this is a two way of the summarizations. You can do that, and you can just basically configure the summarization in different way. Any doubt, any questions still here? No? Okay. So if I conclude the OSPF,
Question.
yes.
So, as far as the summarization is concerned, you took like a 192, 168.10 that, 0 or 1, 2, 3, 4, 5, 6, and then you converted it into like what is the process as to like, how did you come out with the 192, 168.0.0 and then the subnet
Okay. So
mask
you're talking about
over?
how the summarization is going to happen, how summarization happen in this network that you mean?
Yes.
So see, if you go for the summarization, so if you might be learning the CCNA, like network summarizations. So network summarization is basically for IP subnet. There is a process, right? So you have to turn on bit and turn off bit. So basically they use the, let's suppose we have the CIDR concept and we have to do the supernetting. Supernetting is basically summarizations, means any long prefix you have and you want to make a short prefix. So that is going to be basically, give me 1 second, guys. 1 second. Somebody's. Sorry, guys. So I was talking about, right, like you have to understand battalion, right? CIDR concept and supernative concept. Might be you have learned in the CCNA how summarization is working. So summarization is basically a process. If you have the long subnet, let's suppose these are the subnet 0, 1. These are the /24 subnet. So you have to find the like that is a bit that is going to be off bit and on bit, which is going to determine your longest prefix match, which is going to be as a summary route. So first you have to convert the binary, translate the binary format, and then you have to turn on and turn off the bit. So there's a complete process. I'm not sure you guys learn in CCNA or not, but let me show you something. training document. One second, let me find my CCNA. Where it is. CCNP, where is my CCNA? CCNA module, but still it's not have this CCNA module. I want to see the calculation. I have the Excel file, proper Excel file, so you can do the summarization. When I find this, okay, let me. Okay. Anyone know ending process? Ending process. Anyone know that? What is the ending process? It's out of the topic, right? So see, you have to convert the your binary bit, whatever you have the IP address. Let's suppose this is the IP address. You have to convert the binary bit, and you have to convert the your also that is the subnet mask. And you have to find, like, let's suppose how many IP you want to get, how many subnet you want to get for that particular range. Let's suppose you have /24 subnet, and you have multiple /24 subnet, and you want to club on those /24 subnet into one subnet. So you have to make sure how many bits from the subnet side I should turn on. Means turn on means they should be 111, and turn off means they are going to be your 0000. So if you're going to do, let's suppose you required total to the power. Let me do in the online. To the power, if I go here, 24. You're going to that much valid IP address. To the power, if you're going to put the 12, you're going to get that much. If you're going to put to the power 8, 256 IP address. So right now we having the only 8 bit of current subnet mask. We have /24 subnet mask. Okay, battalion. So class current /24, we have a total 256 IP address where 254 is going to valid. So we have to find a range where I can accommodate all these subnet. How many bit I can just make sure turn off, so they're going to become a contiguous bit. So these two are going to be same. 172.16, 122.16 are going to be same. These are the bit where you have to convert. This also going to be same. And you have to make sure how many bits are going to be same. And if they are going to be same, that means their ending process is going to be 0 and 0, right? But if you're going to be different, like if you're finding your subnet mask bit is a 0 and your IP bit is a 1. So in that case, it is going to be again 0. So you have to turn off and turn on the bit, and then it is going to be complete your range, which range I need to use for summary address. So there is a chapter in the CCNA, you have to learn summarizations. If you're not sure about that, so I will take one extra class if you guys need. So I can just convert, cover this summarization. This is a complete science, ending process and all. So summarization is going to be process. It's going to be helpful to calculate that how many bits should be off and how many bits should be the on. So you can see this is mentioning here, convert to binary address, translate IP into binary format. That is the very first sub. And find the common bit. Means how you're going to get the common bit. Means by doing the ANDing process, you're going to get the find the common bit. And that's, you can see this is these all address, right? These all address I have. So these I have this address, this address, this address. So you can see for this range, we're not going to touch anything. For this range also, we're not going to touch anything. This is also 0, 0, but you have this two range, this middle one. So you can see if I use this two IP, two IP, two IP, these are uncommon. So basically, technically, what is going to happen? You just have to count the bit. How many bit we have? We have the 8, 8, 16, 1, 2, 17, 18, 19, 20, 21, 22. So these 22 bits are common. So they are going to be /22 subnet mask as a this. So you have to just write the all your IP, convert in the binary and check which all are same. If all are same, that means you don't have to do any changes. And also always you have to compare from the left side, not right side. Try to see how many bits are same from the left hand side. So if I just give the example like 192.168.11.0, and let me put it this one also, 12.0, if I put it 13.0, 14.0, 15.0, sorry, 15.0, and 16.0. Do practical example. So I want to save some time, else I need to convert everything in binary. So you can find this. See, so with these two bits we are not going to touch because they are same. Only we have variable in this bit 13, 14. So in 13, 14 you can see 4 bits are fixed again. So my subnet mask technically going to be /19 to cater these all bits. But I use the bigger subnet. I use /16 as a random because I want to show in the demo, because if you have the more subnet like 17, 18, 19, 20. So the more subnet you are going to add, the more bits are going to be your off. So technically you see why it's a 19, because 8, 8, 16, right? 8 plus 8 is going to be this bit 16 and 3 bits from here. That is the same. An uncommon bit we are not going to be catered. So, but again, do research on this summarization. Okay, you're going to get some understanding. All right.
Okay, thank you.
All right. So, moving further, I was talking about the AVR and ASBR summarization, and that I believe we covered that. So, this concludes this module for the IPv4 OSPF configuration. Everything I cover, guys, nothing is pending. Everything is covered, and let me move in the different topic, that is my BGP, right? So we're going to talk about the BGP now. So let me stop this. Okay, so if I talk about BGP, guys, why BGP is the useful protocol and what is the use of the BGP, that also we have to understand. So I give the brief idea, like BGP is also one of the routing protocol, and you're going to be always find these routing protocols. Means if you're running any ISP infrastructures, you must be going to get the BGP routing protocol. And why it's important? Because everywhere in the ISP, if you're going to do any like kind of the ISP link termination, any kind of the like configuration to the MPLS domain, BGP is always going to be there. Without BGP, you cannot do anything, right? So if I talk about the BGP, BGP basically used as a path vector protocol. Why it's path vector? Because it's not distance vector. It's not like link state. It's not a like your hybrid protocol. BGP is a path vector protocol. So why it's path vector? Because from the every hop, right? Once reached for the every hop, means once you send the packet from one hop to another hop, that is going to use some attribute, and based on the attribute they're going to find the next hop how to reach further destination. So path is basically they travel to the path, and based on your desired prefix destination address, and then after they will track the what is my AS number, what is my prefix length, what other attribute we have with the configure, then it is going to process. So you can see this is the unlike to distance vector protocol, only not going to check the metric and direction to destination. Link state just maintain the complete BGP. Track the path and packet must, means path and packet. That means every hop, what are the path, which AS it is coming, what is their metric, what other attributes. They have the multiple attribute in all. So based on that, they just go and follow the process. That is your path vector protocol. So if you go here and so also in the BGP chapter, so you can see fundamental of the BGP, you can see from the perspective BGP autonomous system is collection of routers. So I'll discuss what is AS number. So they're just starting for the autonomous system and all, but in the background, BGP is basically exterior gateway protocol. Means they are going to run in the two different entity, two different ISP, and they use the property of the path vector protocol, and they have the multiple way to calculate the metric. It's not like simple way. In OSPF, eIGRP, you have the metric calculation based on the K1, K2, means composite metric was in the eIGRP. We have the cost in the OSPF, right? BGP have some different method, right? They have the different attribute to calculate the matrix. So we'll discuss that as well. But generally, you're going to find this BGP in everywhere in the ISP. So if you just search what is BGP, so BGP is one of the routing protocol, and this routing protocol known as a broader gateway routing protocol. Make internet work by managing the data packet are routed between the different networks across the globe. So this is the significance of the BGP. Means not for the LAN. This protocol not designed for the LAN. This protocol designed for the your WAN infrastructure, for the internet, for the MPLS. And if you want to pass the your prefix information across the globe, then BGP is your most important friend. Without BGP, you cannot do that anything. In internet, anyone know how many prefix we have on the internet? Anyone know that how many prefix on the internet we have?
Yeah, 1.2, 1.3 million.
Million, right? So
Yeah.
it's going to be 1 million route or 1.1 or 1.2 millions. Means in India, it's going to be almost 10 lakh plus routes available on the internet. So to carry the prefix, we require the very robust protocols. If you are going to use the eIGRP and OSPF, trust me guys, your router is going to be completely crashed. Because eIGRP might be someone is going to ask a question, why not we can use the eIGRP and OSPF in the WAN protocol? Means in the internet. Anyone know the region? I just give some hint, but still, what is the reason the router is going to be crashed in the your internet if you are going to use the OSPF and eIGRP?
They cannot handle these many routes. OSPF process.
Why? What is the reason behind it? It's
Like
project.
flooding.
Mm-hmm.
If any routes changed in any one location, it will recalculate the entire world. Means it will cause memory flooding informations. It rebuild the database table, neighbor forming, etc., etc.
Definitely, they work in the hello packet, exchange packet, discovery, flapping. So they do a lot of kind of the process, right? And those processes are going to be very extensive if you have the multiple thousands of lakhs of route, millions of route. Routers are going to be hang, right? They are not going to process that much flooding. Anything is going to change in topology quickly. They just do a lot of conversion, a lot of update and all for the all routers. So those are definitely going to kill the processes. That is the one main reason. Another reason, these routing protocol are not flexible. Means if you want to do some manipulations based on the intent means whatever the company need you have, like policy based routing, you want to do some scalability, some extent of the route aggregation is a flexible way of the route aggregations. That might be not going to be possible in the EIGRP and OSPF. We can do some extent, but the way BGP is flexible, that flexibility you are not going to be find in the EIGRP, right? Sorry, EIGRP and OSPF. The BGP have that particular flexibility. We cannot find in the BGP and OSPF. All right. So if I talk further in the BGP, right? Any company who want to build the BGP, right? So they must have to define their area as a autonomous system. Let's suppose it's your company, you want to build the BGP. So that also have to define one administrative area that is an autonomous system. Means not exactly area like what we use in the OSPF, but yes, autonomous system, EIGRP use autonomous system, same concept used in the BGP as well, autonomous system. So autonomous system is nothing, it's just representing your organizations. Let me open the topology so you guys can understand. If I go here, This is one of the biggest lab we are going to do that in our topology. So let me open that lab. Yeah. So let me turn on this lab. You can see we have the lot of routers. So we have the some administrative distance here, means administrative area here. That is the my AS number 64401. We have this AS number 6455. We have this AS number 64002. And we have the multiple AS number also 64003 and 64004. And also we are using the configuration. So everything we are going to cover in the BGP configurations, redistribution, route leaking, and also I'm going to configure the MPBGP. What is the MPBGP? That is a multi-protocol BGP. So it's a MPLS we are going to cover here. So as I mentioned that BGP is the exterior gateway routing protocol used to exchange your any kind of the network layer informations, means one network, another network they want to communicate. So that is known as a NLRI. So probably you're going to find always this word NLRI. This is known as a network layer reachability information, especially for the IPv4 network, if you want to use that, or IPv6 network. And they use the concept of the AS number. And what is AS number? AS is basically collection of your single organizations, router, switches, firewall, whatever they have, they are going to belong, they be doing the routing. So that is known as the your autonomous system. So you can see here, you can just find here, and organizations require the connectivity of the internet must obtain the AS number. So there are two kind of the AS number also. Means every organization who want to run the BGP, they must require the AS number. But again, AS number is two type. If you want to communicate with the your internal network, you can use the private AS number, right? So that is going to belong to the private AS number, and that you can define by yourself. But if you want to talk to the internet, let's suppose my router want to go on the internet, ISP, then you have to take the public AS number. Private AS number is not going to useful for you, right? So you can see in this, we have the range of the AS number. You can use the range of AS number. There is a two kind of the range, 2 byte 16-bit range, and another is a 4 byte 32-bit range. So if you're going to use the 2 byte range, generally you're going to get this maximum range 65535. This is where you can use the your public and private both. But if you want to use the extended range, 32 bits range, so this is your number 424994967295. This is the number where you can use the your range. And out of this range, you can see out of this range, if you want to use the private address, this range is only reserved for this private, right? Only 64512 to 6535. Rest are the public. Means if you're going to use the other AS apart from this for your internet connectivity, then you have to purchase from your INA that is going to maintain this AS number. So you can see it's important to use only the AS assigned by the INA. For which? For the public. ASN assigned by your service provider or your private ASN using another organization's and without permissions could result traffic loss and cause the HVOC on the internet, right? So the summary is, if you want to assign AS for your company, so you have to understand it's my private AS, means I want to run within the company BGP network. So it's fine. You can use this range, or you can use this range. There's a private AS number for 32-bit range. But the moment you want to go for the any public range, then you can just have to ask from the ISP. ISP must give those range, and then only you can use that. If you're not going to give the ISP, not going to give this range, that is not going to be possible. You cannot use that, right? So what is the BGP? So if someone is going to ask what is the BGP, so BGP is a border gateway routing protocol. And let's make the if you want to make the connectivity with the network connectivity with the ISP, different company SCLB Pro, any US bank, any Canada bank, they want to communicate, so they have to use the BGP. core concept, they use autonomous system. Autonomous system is going to be your 2 bytes or 4 bytes. 2 bytes range is going to be maximum 1 to 65535. But there is a private AS and public AS. Similarly, you have the 4 byte AS number, you can use that. This range is quite big. BGP always talk between each other and exchange the route, but they have the two format. The BGP, if you're going to configure, the BGP is going to be configured in two way. That is, one is the iBGP, another is the eBGP. So you can see, if you want to configure the BGP, there is two concept, iBGP and the eBGP. So what is iBGP and what is the eBGP? So let me explain in the whiteboard. Let's suppose this is my one company. Think about this, the SCL in India, and this is my another company. Let's suppose AT&T in the US. They want to communicate. So SCL inside, a lot of routers are going to be there. R1, R2, R3, right, and R4. They must have some sort of the connectivity. This also have some routers, R1, R2, R3, and R4. Right. So the moment you are going to build the BGP network, in this BGP network, you must have to identify your AS number. Means every company, they have the AS number. They can use two AS number. They can use a private AS number, right? They can use the public AS number. So this can be also, they can use the private AS. They can use the public AS. So where they can use the private AS number. Private AS number, if they want to communicate within the your autonomous systems. Means this is your company and you want to maintain your own autonomous system. So you can use any private AS number. So they can form the BGP here, 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 and here. So you can use the private AS number. This can be PAS, private AS, sorry. But if you want to go with the one ISP to another ISP, in between you have the ISP network and you want to make the connectivity to two different company. So this ISP will never recognize, similar to the public IP and private IP address. It will never going to recognize what is your private AS number. It will simply ignore because multiple people are using this private IP address. So in that case, what is going to happen? You must have to make sure use the public AS number, and public AS number assigned by the INA, right? So the only public AS number is going to be communicate. So public AS number, here's the public AS number. So this is going to be public AS number. Now, public AS number for my company, listen carefully. Public AS number for my company and this company cannot be same. They must have the different. So if I have a different public AS number, then this BGP is known as the external BGP, eBGP. The public AS number is going to be different. That is going to known as the external BGP. But within the company, I have the private AS number and I'm running the BGP. This can be your iBGP. This is my internal BGP. Here also I can use the iBGP. Okay, generally we do the iBGP. So within the company, if I want to run BGP, I can use the private AS number, right? We don't want to use the public AS number, and these can form the iBGP. But when you go for the one company to another company, this is always going to be eBGP. eBGP means they are going to connect to two different AS number. So you can just read it here.
Sir, can we use same AS number on both sides?
We can use
on
that.
both sides?
Yes, we can use that. Absolutely, we can use that.
Okay.
There's no problem. But if you're using the same AS number, that's internal LAN is going to be known as an iBGP. But we are going to make with the peer with the different AS, that is going to be eBGP. In our case, also you can see, in this case, we only one AS number. You can see here, only one AS number. This also facing to the IISP within the LAN as well. So we'll do the same configuration here.
No, I'm asking like on either side of the ISP. can we use the same AS number?
No, they cannot.
Not possible.
ISP cannot, because unique IP AS number is going to assign by your provider or the INA. So it cannot be same. Your address, my address cannot be same, right? Your
No,
model number.
no. I'm saying on the either side, like this one is the, let's say ISP, the MP-BGP side is the and then branch 1 and branch 2. Can they have same AS number, branch 1 and branch 2? Private AS number is what I'm talking about. Private AS number.
Private AS can be same, yes. Private AS you can use the same. Yeah, that's correct. Private AS, anyone can use that. Similar to private IP address.
Okay.
So private AS never going to be routed on the internet. It's always going to stay in the local to the internet. I mean local to the LAN. Okay. So private you can use always same AS number. Similar to the private IP. I'm using also 192.168. You also using the same. It doesn't make any sense, right? It's not going to make any impact on the internet because this is not routable.
Yes.
Similar way,
Yes.
it's a AS number as well.
Yes, sir. I got it. Thank you.
Okay, so if I go again in the book and you see here, internal BGP session established via the iBGP router that are the same AS number and participate in the same BGP confederation. What is a confederation? Confederation, we'll discuss about that. This is the AS. Within the AS, we want to build the sub AS and you want to make the BGP neighbor. That is the known as the confederations. So this is the one set of the things we'll discuss later on. But yes, this also you can take a note. External BGP session established with the BGP router that are different AS. Right? They are going to be known as a different AS. Clear till here? Any doubt anyone have regarding the BGP till here? Or we are good?
Yes, sir. We're good.
Okay. Now we have to talk about, right? We have to talk about BGP attribute. Means if I talk about the BGP is basically going to use a lot of attribute. So let me go in whiteboard and explain one by one what are the attribute. So probably you are going to find that is the known as the path attribute. In this path attribute, you are going to get a lot of attribute. One is going to be your well-known attribute, right? And another is going to be optional. Optional is basically it's going to be optional, or you can just put as the manual. Means we can just put the manually. You can just put the attribute informations. And further, they are going to be like in two part. Well-known is going to be two part. One is going to be your mandatory, right? And another is known as a discretionary. So this is going to be discretionary. Okay, this is going to be your another attribute. And here is going to be your transitive. Transitive, okay. And one is going to be non-transitive. Okay. So let me draw this. So you can see this is the path attribute. We have the two path attribute, optional, that's mandatory, discretionary, optional transitive, and non-transitive. Further, if I go here, you are going to get the attribute like one by one. That is one is a next hop. That is one attribute. Second, you might be going to find the AS path. Now we have to understand these all step by step. And third is going to be origin code. Origin code. We have to discuss what is the origin code. This is going to be your I, E, and third is a question mark. We'll discuss about this as well. Discretionary, you're going to get as a first as a LP, that is known as a local preference. Right. Second, you're going to get as a atomic aggregator, which generally we're not going to use aggregate. So that is a more important, right? And that also in transitive, we're going to get as a aggregator. And second, we're going to use the community. That is a most we're going to discuss. Community also, you not worry about this one. And here we are going to get as a MAD. That's very important. We have to understand the origin ID. So origin ID, and third I'm going to get the cluster list also. So this is especially for the your configuration and all. So there are different attribute we have. So if you go in the book as well, you can going to find the well-known mandatory, well-known discretionary, right? And that is optional transitive and optional non-transitive. You can see it's matching the same syntax here. You have the well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. So these are the attributes you guys can take a note, and these attributes are going to be used for your all kind of the communications. So if I talk about the attribute, right? So next hop means what is the next hop? I'm just saying theoretically, but we have to do it practically as well. Next hop means why it's mandatory means any prefix must have this next hop informations. Means if you're going to learn any route from the any neighbor, you must have the next hop from where this route is going to learn. So every routing table is going to carry that route next hop informations. That's why it's known as the next hop attribute. Make sense? So that is your first attribute, that is your next hop. Now AS path, because we know that every prefix is going to come from the AS number, because if you are going to originate any route, that is going to be originate from the AS number, because every ISP, every organization must maintain the AS number. And if this AS number is not going to be there in the path list, then what is going to be happen? The problem is you're not going to identify from which AS this particular prefix is going to come. So I will show you, you're going to find that every route is going to have the AS number. I'm giving the overview, but we'll see in the practically these all attribute again. But just understand the overview. Origin code means what is the origin? Means it's the internal route of the BGP, your external route of the BGP, right? It might be going to be any redistributed route of the BGP. So every route which is going to be injected in the BGP domain, they have some sort of the origin code, and that origin code must be going to match in the your routing table, whatever the origin you are going to do that. So this is a mandatory. So means every route which are going to part of the your BGP routing table, they must have three attributes. 100% they have the three attributes. But in discretionary, it is not mandatory. You just have to define this attribute. It is optional. You want to put this in your BGP table for the routing updates, you can do that, and you cannot do that. Choice is your, like you have the local preference. I will discuss what is local preference. This is the like one of the attribute. If I want to inject on the route, I can do that manually, but it's not mandatory. But this is always going to be there. If I want to use automatic aggregator, it's also going to be there. Similarly, optional we have. Some are going to be transit. Transit means this attribute is going to travel from one AS to another AS. So these two attribute, if I'm going to apply, they can travel from one AS to another AS. But it's also like not mandatory. It's you have to use as a optional for the advanced troubleshooting, advanced configuration. But they can travel. This attribute can travel. But if you talk about non-transitive, this will stay within the AS. This will not travel. So this you have to understand. Means mandatory means it is always going to be with the prefix. Means what are the BGP you are learning. Discretionary means it's optional. It is if you're going to configure, it is going to be available with the prefix, and it is going to be there with the prefix. Transitive, it is going to travel from one AS to another AS. It's going to travel from the different AS. Non-transitive, it is not going to be travel. It is going to stay within the your same AS. So that is the history behind it, but we have to talk more about it later. But let's do some small lab. Let's suppose before we do a lot of theory, understand how to configure the BGP. So whenever going to design the BGP, let me use this very small topology, guys. Very small topology. Then we'll go for the big topology. First, understand the very small topology. where let me do one thing. Let me wipe the configuration. I will not use any configuration. I will do the fresh configuration of these three routers at least. Let's wait. So important part is whenever you're going to design the any BGP network, along with your IP schema, you must have to think about your AS number as well. If you're building your own internal network, you can decide your own private AS number. But if you're building your ISP network, you have to purchase the AS number from your ISP. So this is the responsibility of network architect, network designer who can take care of the your IP schema and network design. So I'll go here. I'll go here. Okay. So I will do the very phrase configuration step by step for this, and we'll see how it is going to look like. So config T, if you go here, host name is going to be R2. Do right. Here go config T, host name is going to be R1 and do right. And config T, host name is going to be R3. Sorry, I believe mistake, should be the R2. Okay, that's fine. Okay, so we are done. Show IP interface bib. So I will simply configure the IP address on this interface, Ethernet 0 by 0. So what IP address I'll configure? This is going to be slash, let me put that 13.0.0.0 slash 24. Okay. This is the IP address for this link. And here we are going to use the link as in 12.0.0.0 slash 24. So I will use 3.1 here. Sorry, 3.3 here, 3.1 here, 12 dot. I can use that. Let me delete this. Not needed now. This also not needed. I'll use that 12.1 here and 12.2 here. And we have the all three loop back. And you can see also AS number. For this router, we have AS number 300, 100, and 100. So one, we are going to build the iBGP, and one we are going to build the eBGP. Very small topology, guys, to start the learning. So we'll understand how first build the BGP neighbor, what is syntax to build the BGP neighbor. And once we have the BGP neighbor, how those network are going to be advertised in the BGP, like OSPF and eIGRP. We have done the advertisement of the network via the network command, not network. Yes, we use the network command and we give some network ID and their wildcard mask and then area in case of the OSPF. In case of the eIGRP, no area, just network ID and the wildcard mask. Here also we have to use the same process, but let me first assign the IP address. I'll go here config T and this interface Ethernet 0 by 0 IP address is going to be 13 0.3 55 55 55.0 no shut interface loopback 3 IP address 3.3.3. Okay, this is done. And you can see here, show IP interface brief. Sorry. Now I'll go for the R1. I'll configure the interface. There is two interfaces I need to configure. Ethernet 0 by 1. So I'll go Ethernet IP address 13.0.0.1 255. No shut. I'll configure one more interface here. Ethernet 0 by 0. 12.0.0.1 255 255 to 12.0. I'll configure the loopback 1. IP address 1.1.1 255 255 255.255. Right, do right. So you can check show IP interface. And if I try to ping 13.1, it's going to ping. Now I'll go here. Sorry, config T. I need to configure this Ethernet 0 by 0. IP address is going to be 12.0.0.2 to 55. No shut. I'll try to ping first 12.0.0.1. Should be reachable. Yeah, reachable. I'll create one of the loopback, interface loopback 2. 2.2.2.2. Now I can just write show IP interface. Okay. So we are good here. We configure this IP address and the loopback, configure the IP address and loopback. What is the next step? We have to build the BGP. Which BGP? That is going to be my iBGP and eBGP. So let's first build the iBGP. iBGP, that means the router should have the same AS number. The router should have the same AS number. So this router have the AS 100. This router have the AS 100. And one single router can carry only one AS number. You cannot configure multiple AS on the same router. No. If you have the router, so only one AS you can configure on the router. You cannot configure the multiple AS number. So in this case, if I'm going to talk about my BGP is going to be formed between these two routers and they have the same AS number, you can see. That means this is going to be your iBGP, which is known as an internal BGP. Similarly, if this router want to form the BGP with the AS300, like this one, but they have the different AS number, so this is going to be your eBGP. Clear? So if you're forming the two different AS neighbor, that is going to be eBGP. If we are the same AS number, that is going to be your iBGP. So we are going to form this neighbor between this. Now, how I can form this neighbor? I can go in the router 1 or 2. I can go here router. I can just go configure router BGP. This is the first command, like router OSPF. And I need AS number 100 here. So I'll give the 100 AS number. Clear? If you want to give the router ID, you can give the router ID. If you're not going automatically BGP router ID, there's a command BGP router ID. You can give the 1.1.1. So this is router ID. It's optional. You can give, you cannot give that. Now, so BGP and BGP router ID, two things I define. Now, I want to form a neighbor with this router. And what is the IP address? There's a two kind of the neighborship can be formed. Listen carefully, guys. In BGP, listen carefully. You can form the neighborship with a directly connected interface IP address or via loopback as well. And both are going to stay as iBGP. Both are going to be stay as a iBGP because the AS number is same. Or what is different between a directly connected interface and the loopback? So directly connected interface is going to by default reachable. By default reachable, that means they are able to ping. But if you're going to build the BGP with the loopback address, as of now, you cannot make the ping because BGP is not configured, so you cannot make them ping by default. So if I'm going on my R1 router, and if I'm trying to ping, let me go in the R2 first because here I'm doing the if I'm trying to ping 1.1.1, I cannot ping it. So if I am not able to ping, I cannot build the BGP, even the iBGP. But 12.1 directly connected interface, I can able to ping. If I go here and try to ping this IP address, it is pingable. So I can build the BGP. So moral of the story is, if you want to build any BGP neighbor, it's the iBGP or eBGP neighbor, doesn't matter, any address, make sure those addresses are reachable. So if I want to make them reachable with any IGP protocol, not BGP I'm talking about. Listen carefully, guys. If I can make the reachability of these two address via any IGP, let's suppose I can make them reachable via the static route, or I can run the OSPF between these two router and I advertise the loop back. So they are reachable. Then I can form the BGP here. No problem. The first conditions, whatever the neighbor you want to build, they are reachable. If they are not reachable, you cannot form the BGP. That is your next hop should be reachable. That is a NLRI reachability concept. NLRI, next hop reachability information. If next hop is not available, reachable for any prefix or any neighbor, you cannot form the BGP. You got my point, guys? Clear this one, what I talk? Dinesh, Sakil, Sridhar, Tuan, Amrita, everyone, guys.
Yes, sir.
Okay, so make this a special note. So now I am just going to show on the my directly connected interface first. So let me just go and form the BGP, and I'll put the neighbor. Neighbor is going to be 12.2. So 12.2 and remote is you have to give as a 100. That's it. So your one side configuration done. Let me show you again. Show run section BGP, and we done with this configuration. Just this. I use this router BGP router ID. This is the by default log command. It's taken by the iOS. I haven't defined this. And this is the neighbor 12.0.0.2. And now if you check the show IP BGP summary, you see my neighbor is in down state. Why it is showing in down state and what is the states, I will also discuss about that. But hold on, it's showing in down state. And this is my local AS number, and this is my remote AS number, neighbor AS number. Both are same. That's why it's a iBGP. Now I'll go in the R2 router, configure router BGP 100. Okay. BGP router ID. It's going to be 2.2.2.2. Neighbor is going to be 12.0.0. It's going to be your 1. Remote AS is going to be 100. That's it. Now, see. After some time, you are going to see that your BGP is going to become online. See, this command is showing that BGP neighbor change and your neighbor BGP is come up. By running these two commands, we found that my BGP is automatically come online. So if I run the command show IP BGP summary, you see now my BGP is up and working, but there is a state prefix 00. If I run command also show IP BGP summary, you can see this is also good. There is no problem at all. Make sense? So we have the iBGP configure between these two neighbors. Now we have to configure the eBGP. Okay, I'm just doing the plain BGP configuration. So I want to do the eBGP configurations. So I'll go again in the R1. R1 have the two neighbor, R3 and R2. So I'll go and complete the configuration for the R1. So I'll go in the R1 again. And again, I have to use the same router BGP 100. If I use the any other AS number, say it's throwing error. I pushed mistaken 101. So it's not taking my AS number. It's showing that BGP already running on the AS 100. So you cannot change it. You must have to use the AS 100 only. And now I'll define the neighbor is 13.0.03 and remote AS is going to be 300. What is this address? This is this address. You can see 13.0.0.3 remote address is my 300. Done and done. So you can see this is a new configuration of the BGP. All right, now I'll go in the R3. If I'm going in the R3, config T, right? There's no BGP, so router BGP 300, BGP router ID is going to be 3.303. Neighbor is going to be 13.0.0.1. Remote AS is going to be your 100. Done. And the moment you will do, you will see after some time, you are going to be get the BGP up and working. Wait for a few seconds. See, your BGP is up and working. So if you run the command show IP BGP summary, you're okay. Now you can see show IP BGP summary. It's also okay. I hope this is clear to all. Any doubt till here, guys? I'm just taking as a no doubt, okay? Everyone good. All right. Now, moving further, we have a requirement from the BGP. See, not talking about neighborship. To build the neighborship between these two loopback is a different concept. We may have to make the reachable via the IGP. But we already have the neighborship between these two routers. We have the neighborship. Now these subnet want to talk to each other. So how they can talk? We need to advertise this subnet in the BGP. So once I advertise BGP, it will travel from here, it will reach here in routing table. Similarly, I'll advertise here and it will reach here, it will reach here. Similarly, I will go here, advertise in the BGP, reach here, and this will also reach here. So how to advertise any network into the BGP so it can reach to another neighbor? So there is a three method we can advertise route in the network. First is network command by using the network command. Second is by using the aggregate command, that is summarizations. And third is basically redistribution. So you can use either of these three methods to advertise network into the BGP. Means if you want to advertise OSPF route in the BGP, so you have to use the redistribution command. You want to use the any kind of the summarizations. For that, you have to use the aggregate command. If you want to normal advertisement, most of the time you are going to get a normal advertisement. That is a network command. So by network command, we go and advertise the route in the BGP. So I will go in my R1. I will go in my config T and do show run section BGP. And network command, we have this network. In this R1, we have the 1.1.1. So 1.1.1. And you have to give the mask, subnet mask. This is done. The moment you will done, you can see this is my configuration, show run section BGP. You will see magic is going to happen. This 0 is going to become 1. See 1. This also 0 is going to become 1. That means you start receiving one prefix. You can verify this prefix by running the command show IP route and see you start getting a BGP route from which neighbor? 12.1. And also you can check here, you start getting a route from your neighbor 13.1. So this is how we can advertise. Now, so if I start getting this route, I can advertise this one from my R2 and it will reach to R1. So I will go in my R2, router BGP 100, network 2.2.2 and mask 255. And you will see this will also start getting one of the route. So iBGP summary. See, you start getting from 12.2 neighbor. Still, this is not advertising 3.3, so it's not getting here, but it is start getting here. So if I go and check now, show IP route, you start getting 2. And you want to ping this with source 1.1 should be reachable. Say it is reachable. So now we have the reachable. Earlier it was not reachable, but now I'm able to reach from this to this. Similar, if you try to ping 3.3, it is not going to reach as of now. If you try to ping 3.3 with source, it's not pingable because we not have the route from the my R3 to the R1. So I need to advertise this also from the R3 to R1. So I'll go in the R3 configuration terminal and router BGP 300 and network I go advertise. Sorry, 3.3 dot. And you can check it here. Probably if you try to ping, you're able to ping because you start getting the route. Clear? So you have the iBGP and eBGP enabled. And if you run the command show BGP, sorry, so IP BGP, just this command, you say these are the 3 prefix we are running here. And this is I indicate this is the iBGP route. You can see this I is indicating this I indicating this is the iBGP route. If you don't have any I mention here, you can see this is the internal route. I is equal to basically internal route, and this you have to check. This is basically indicating this is my iBGP. This is my external route, and this is also BGP route, but this is the self-originated BGP route. So you can see all this flag, and you can see origin code is I, E, or this is my question mark. Question mark is basically incomplete. So we'll discuss about this in origin code later on. What is this origin code and why basically we use this origin code later on. But yes, this is how we can check the neighbor. Now, one more thing, guys. There is a process, right? If you check that I build the BGP neighbor, by default BGP what do that? Listen carefully. Something very important. I advertise this 3 route. It reach here, right? This is the eBGP neighbor. Now, if I have another iBGP neighbor, this will send to this neighbor. So let's verify. Are we receiving this 2.2? We haven't done anything. We haven't done anything. And let's verify. If I go in the R3 and if I check the show IP route, it is not coming, but should come by default, right? Because we have the BGP, so should come route which is learning from the eBGP. But we not have any route. Okay, that's fine. Now, similarly, you can check for reverse direction. If I send any route from here to here, that is my iBGP again, the 2.2, and this should reach to the this router. That is a eBGP, the 2 subnet. Okay, so let me check that. So R1 we have this 2.2, and let me check in the show IP BGP, and we are receiving this route, right? We are receiving that route. But why the my eBGP route means if I try to ping from here 2.2.2.2, it is not pinging, and that is not pinging. There is a valid reason because it is going via the source this 13.13.0.0.3, but this source is not available in the R3. If you go check in that, let me debug IP ICMP. Let me try to ping again. I don't know, it's going to show the okay, see, so the source is coming this one. You can see source is coming this one. Your packet is reaching to you, but you're not able to reply because you don't have the information of this source. This router doesn't know this source, so they cannot reply. Okay, let me try to change the source. I will change the source 3.3.3. Again, let me put the debug. Let me put the ICMP. Let me try. Again, it is not going to be ping. Why? This router again don't know this source 3.3.3, but we advertise in the BGP. We advertise this source in the BGP. So here you can see this 2.2. It's coming from your iBGP neighbor, right? And it's going to the eBGP neighbor. This is successful reachability. But the route coming from the different direction, this one is reaching till here, but this router is not sending back to the here. What is the reason behind it? Anyone, any idea? What is the reason behind it?
The next hop.
No. Okay, next hop. Let me set the next hop. You're saying that. So let me try. Your route is not coming. Sakil, next hop is going to come in picture if your route is coming. Okay.
Okay.
Your route itself is not coming. Next hop is going to come in picture. If your next hop is wrong, then it is going to be there. Any other thoughts?
So router 3 and router 1, they're eBGP.
Yeah, eBGP, right?
Okay.
This is iBGP.
The split horizon.
Split horizon, right? Okay, so let's learn about what is a split horizon. Split horizon in BGP. This is one topic. Tuan just mentioned that split horizon fundamental loop prevention mechanism, especially is the iBGP. So there is a one concept in the BGP that is a split horizon, and the rule said a router cannot advertise route learned from the iBGP to any other iBGP. But are we learning this route from the iBGP? We are learning this route from the eBGP. Should send, right? So this is not a split horizon problem. So let me try to check it. Why it is not going there? Show IP BGP. Okay, so you can just go here and show IP BGP table. You can see this route is coming and Sakil is right. Right. I was thinking this is iBGP. Sakil was right. Split horizon route is not going to be there. The problem with the next hop reachability. I just forgot this one. The problem is the route is coming in routing table, BGP table, but not installing in the routing table. So a split horizon rule is going to say that, let's suppose this scenario is going to be happen to An and everyone. If this is my R1, this is my R2, and this is my R3. If all are the AS100 means they all are going to be iBGP. So if I'm advertising the 1.1.1.1, it will reach till here 1.1.1.1, but it will never going to advertise to the my further peer. This is the split horizon rule. Means don't teach my father. Means anything is learning from my side. You're learning as a your neighbor. This is never going to be advertised further to the router. I was under impression that only, but the actually Sakil was right. The problem is I never verify the BGP table. The route is receiving in the BGP table because this is the eBGP route. An eBGP route further can advertise to iBGP peer. That's correctly fine. And that was my expectations. But some reason I overlooked that output of the BGP. So in that, what is happening by default in the BGP, what happened? Any eBGP is going to send as a route. They carry and preserve their on next hop. Means where the route is going to originate, that is going to be carried by default there on next hop. So if I want to change this next hop, I need to use the special command next hop self, or if this command is not going to work, I need to make them next hop reachable via the any IGP protocol. IGP protocol. So right now my next hop is inaccessible. You can see here. See, if I just run this, show IP BGP 3.3.3/32, you can see this is inaccessible. Means I'm not able to ping this next hop. If I'm not able to ping this next hop, this router is no more valid for my routing table. The asterisk is basically it's invalid route. So how I can fix this issue? To fix this issue, I'll go in my R1. Okay. Config T and do show run section BGP. And I will use this neighbor. The neighbor is my this neighbor 12.1 next hop cell and clear IP BGP. Okay, I'll just clear the BGP to just reconverge. Now we'll check again. See, now we fix the issue. So if you fix the issue, if you run the command so iBGP, your route is become valid. Why it's become valid? Because next hop it was just carrying your eBGP. By default, it's not changing the any eBGP route while sending the iBGP. So we just preserve the same next hop, but I change the next hop by using the network command, means BGP configuration command next hop cell. Then we have this reachability. And now if I try to ping from here, 3.3.3 with source 2.2.2, it is reachable. And if you also go here, it is also going to be reachable. A date was not reachable. So this is how we can fix the issue, right? But in case if this is also going to be AS100, that your split horizon is going to come in picture. This was clear to everyone? 300, 100 and 100. All good? What I have done till now? Now let me do the one more practical. I will change the AS number 100 here also. R3 also going to be 100 AS number. Instead of 300, I'll go use the 100 AS number. So you can see I'll just, sorry. And I will use this. Now we have the complete iBGP. Show iBGP summary. Show iBGP summary. See, they are going to form the, okay, let me configure here also. This is wrong configuration they said. So let me correct the configuration here as well. So actually I need to change the configuration. No neighbor. This one, I need to use this command. Okay. 100. Okay. So you can see now we have the 100 AS number everywhere. Both are 100 AS number. You can check here, show iBGP summary. It is going to form the BGP. Now we have the neighbor sieve up and working. This also have the air sieve and all are the iBGP. Now in this case, you can see we have the everything, but R3 route is going to be in R1. You can see the BGP table. R3 route is coming, means 333 is coming, but this 333 is never going to advertise to the my R2. So if I go in the R2, show IP BGP, this is not going to come. This is the region of the split horizon. So split horizon is basically any iBGP route never going to be advertised to further any iBGP peer. So how we can solve the problem? To solve the problem, we have to make the full mass iBGP. Means we need to create the iBGP directly from this to this. So we'll discuss this in this particular MPBGP lab when I do that, how to solve this problem. There is a configuration also, we have the options. And if you want to go and learn the advanced topic like AS overread and allow AS in, there's two more command available that also we can use to just do that particular resolution. So this is how we can do the iBGP. So I believe we are good till here, guys. And I wanted to start this lab, but let's start this lab from the next week. And we'll do the configuration from scratch. We'll try to build this configuration, build this configuration, everything IP assignment on all, and then we'll start doing the configuration step by step for the next class. Will it fine? Any
Yes,
question?
sir.
Okay, then good to close. And let's meet next week, guys. Thank you. Happy learning. See you. Bye-bye. Take care.